So you're currently on slide 7. I want you to go to slide 8 right now, in whatever state of doneness slide 7 is. Go to slide 8 and make the length and the width both 4. So mark the length and the width both 4. On slide 8. So go to a blank slide. We're going to do some together. We're going to use each other's measurements as kind of examples. So we had 4 and 4. If my angle is this theta, you're learning Greek today. That's a Greek alphabet, theta. What's the O? The 4 over here, and it's even marked. And what's the A? The other 4, it's even marked. And I don't have a hypotenuse, right? So I can't use sine and I can't use cosine because I need hypotenuse for both of those. So this is where I'm kind of forced to use 1. So I've got tangent and 4 over 4. When you put that in the calculator, what do you get?
90.
90?
Yeah.
Tangent negative 1, 4 over 4, close the parentheses, and it should be 45. So this angle is 45, which means what's the other angle? The same. 45. Boom. And this is an isosceles triangle, so that makes sense, right? If I know one angle is 90 and the other 2 angles equal each other, then it should be 45 and 45. Okay. Let's go to the next slide. So your next clean slide. And I'm going to give you somebody else's example numbers. So there was a 29.
Can you go back?
I can, yeah. Give me a second. 14.5 and 25.5. 25.5. Those are the 3 side lengths. Okay. Where do I put those 3 numbers? Absolutely. Oops. So the biggest number is the hypotenuse. Okay. So I've got 14.5 down here for the leg. That's the A. And that leaves me 25.5 for the O. Right? So now I've got to choose. It doesn't matter if I use sine, cosine, or tangent. I've just got to pick, I've got to create the right ratio. Sine, cosine, and tangent. So we already did tangent. Let's choose between sine and cosine. And it shouldn't matter which one you do. Okay. If I use sine, what fraction do I use? Opposite over hypotenuse. So 25.5 over the biggest one, 29. Or I can use cosine negative 1 of the adjacent over the hypotenuse. So adjacent is 14.5 over the hypotenuse, which is 29. So do both of those just to prove to yourself that it doesn't matter which one you use. Inverse sine 25.5 divided by 29. And what do you get for an angle? I got 61.6. Did I not do it right? 25.5 over 29. And then you're in radians instead of degrees. So are you using the Desmo calculator? Oh, and I did get 60 on this one.
Yeah.
Did you get 60 on both of them? So we measured. I think the reason we're not getting the same thing is because we measured. So one of these sides at least has been rounded. Okay, so this is a rounding error. These are going to be close enough. They're almost the same. If you're not getting these numbers, then what you need to do is check to make sure that you're in degrees. Are you in the Desmo? So the little wrench up at the top in the upper right-hand corner, click on that. And at the very bottom, it should have radians and degrees. You want to make sure degrees is in green. You're welcome. I told you I worked at that surveying company. I was trying to do calculate some trig at one point, and I was like, why am I not getting the right answer? This is so not reasonable. And I fought with it for about 10 minutes, and I'm like, damn it. My calculator needs to be in degree mode. So frustrating. Yeah. There'd be no reason for you to.
I was getting kind of frustrated.
Yeah. So don't sit in frustration. If you're getting weird answers, call it out, because I guarantee somebody else is getting weird answers too.
Halfway, I kind of blew up. It's still drawing.
Oh. Okay, let's go to a new slide now that we're almost all together on the same page. Let's look at another example. So I saw somebody had, and I'm getting tired of looking at purple, so I'm going to go to orangey red. I saw 3, 6.5, 3, 6.5, and 5.1. Yeah.
How do I figure out which is A or not A and O?
So let's look at this one and we'll figure that out. Okay. So where do I put the biggest number? Always the hypotenuse. That's the easiest one. The hypotenuse is always opposite from the right angle. So if I draw a line, draw arrows through the center of my triangle, that's how I find my O, my A, and my H. So that's going to be the hypotenuse. It's always the biggest angle or the biggest side. Now I've got this angle that's marked. So that's the one that I'm looking for, theta. If I draw another line straight across to the other side of the triangle, that's the O. And we've been putting the medium side there. It's not always going to be that, but we've been doing that because the theta is the medium angle in our triangle. And then we're going to make this one the A. And because that kind of is sloppy handwriting, I'm going to make that look like a real H. So does that make sense? The O is opposite the angle that you're looking for, and the A is adjacent to it. The hypotenuse is always the hypotenuse. So now we've got to choose SOH CAH TOA. We did sine and cosine last time. How about if we use tangent this time? Okay, so we're going to do tangent. And what do I need for tangent? Opposite and adjacent. So we need the O, the 5.1. And we need the A, which is 3. So in your calculator, my calculator keeps turning off. I feel like it needs to be charged. 5.1 divided by 3. And what do we get? 51.7. 5.1 divided by 3. I got 59.5. 59.5. So this guy is 51.5. So if I go into Desmos, tangent -1, and my numbers were 5.1 and 3. 5.1 divided by 3, 59.5. So if I know the medium angle is 59.5, what's the small angle? What's this guy up here? We can call it Y. So in any right triangle, you can use sine, cosine, and tangent to find the angles, as long as you know what the legs are. So if it's an isosceles triangle, there's something else we're going to do, but we got to get good at this before I complicate your life to do that. Okay. I don't know. I'll show you in a minute what the folks in class did for me yesterday. that I hope everybody can come in and see at some point. But the way I made these puzzle pieces for the thing they put together yesterday was using isosceles, triangles, and trig. So let's do one more example just to make sure we're good. Okay, Elias, make sure you're staying up with us and not just screen capturing it at the end and then copying it down. You're not going to understand it if you're just doing that, okay? The only way to learn how to do it is to do it. Okay, so I want you to talk me through this one. The only voice I want to hear is Elias's. I've got a side of 4, a side of 2.5, and a side of 3. What's the first thing I put in my triangle? The 4. Where do I put the 4? Which side is that? Perfect. Where do I put the 2.5 and the 3? And I'll give you a hint, it really doesn't matter. I just fill it in. 2.5 is now the O because it's opposite from the angle we're looking for. And the 3 is the A because it's adjacent. Now we got to pick a function. Do we want to use sine, cosine, or tangent? Again, it doesn't matter because we've got all 3 sides. Okay, let's do that. I like going with easy. And I agree, tangent is nice because it's just the 2 legs of the triangle. Which one's the O and which one's the A? Which is the numerator and which is the denominator? Okay, so let's rewrite this. Tangent is O over A. The first thing always goes in the numerator and the second thing always goes in the denominator. So cosine is A over H. Does that help? And sine is O over H. So these last 2 things are just a fraction. Okay, so I'm glad we chatted. So what's the O? Yes, sir. And what's the A? 3. So we're going to put that in the calculator. About what? So this is our angle, this theta. So if I go through the triangle, that's always the opposite side. And then the next door neighbor is always the adjacent. So because we put the 2.5 over here, that's the smallest now. Because that's opposite. So what we said was it didn't really matter where we put the 2.5 and the 3. So the opposite is always not always going to be the medium, and the A is not always going to be the smallest. So I'm glad we did it this way. So when we do tangent, inverse tangent, 2.5 over 3, what do we get for an angle measure? Elias, what'd you get for the angle measure when you put that in the calculator? Okay, so what calculator are you using? Are you using your phone, a handheld calculator, or Desmos? Okay, so in Desmos, can you see my screen? Okay, I'm going to close out all of those. You want to go to this little wrench up in the corner, open that little wrench and make sure degrees is in green. If radians is in green, click degrees. In order for trig to work in Desmos, that has to be highlighted.
So when we type it in the calculator, all we have to put is 2.5 over 3.
That's it.
Okay, I know.
Go down to functions in your keypad and you will see all 6 of our functions. We in geometry are only going to use these 6, but know that a whole bunch of other ones exist. We're just limiting ourselves to 6, and today we're only using these. So we decided to use tangent, right? And did we do 3 over 2.5? Was that our fraction? 2.5 over 3. So once we get that far, we need 2.5 divided by 3. Boom. And then it gives you, you don't even have to hit enter, it gives you your answer right here, 39.8. Yeah. 39.8. So if I know this one is 39.8, what's the medium angle over here? What do those two angles have to add up to? 90. So 90 minus 39.8 is going to give me 50.2. Did I not do that right? I did it in my head. 50.1. 50.19, which is going to round to 50.2. Okay. Everybody do one more on your pear deck. I'm going to stop sharing. I want you to measure one more triangle of some sort with your ruler. You can just make one up too, as long as it's a real triangle. Put it on slide 14, because I don't think we have anything there yet. So go to slide 14 and put it there. So you're going to measure one more right triangle in some way, shape, or form. You can make one up if you want. You can. Yeah, absolutely. Now you have to make sure it's a right triangle. So if you put two sides, say 7 and 7, you got to do Pythagorean theorem to make sure you know that that third side really is whatever it is, right? You just can't throw in numbers and make sure that it works. So you got to calculate it. 70 squared plus 16 squared does not equal 90 squared, just saying. Well, you can, as long as it's a right triangle, but you got to make sure. So make sure your Pythagorean theorem works. Because if it doesn't work, it's not going to work. 3, 4, 5 is a right triangle. Absolutely. Okay. The C is always the hypotenuse. So, C cosine is adjacent over hypotenuse. Hypotenuse is always on the bottom because it's always the biggest. So when you do tangent, your big number can sometimes be on the top. But when you have sine or cosine, it's hypotenuse is always the bigger number and it's always on the bottom. Hypotenuse sinks to the bottom because it's biggest. You can figure out if it's a right triangle. If you know all three sides, you can do Pythagorean theorem. A squared plus B squared equals C squared. We've done too much exploration and not enough calculating. So let's just go from there and see what this one is. So 16 squared minus 15 squared equals what? Put this in your calculator. 16 squared minus 16. You said you have a hypotenuse of 16, right? And a leg of 15.
Okay.
Yep.
16 squared minus 15 squared.
Uh-huh.
Okay.
And what do you get?
31.
And then take the square root of that.
I don't know.
Should be somewhere around 5 point something.
5.5. 5.5. Well, I mean, it's 5.56.
Okay, so we could do 5.6. So that's your third side. If you got a 16 and a 15, then your third side is 5.6.
Wait, so then how would it not be a right triangle? Like, what number?
That is a right triangle.
No, I know, but I'm saying, like, what numbers would make it not a right triangle?
Anything else? There's only one, with a 15 and a 16, there's only one way to make the right
so
triangle.
It all depends on two.
Mm-hmm. Yep. If you know two numbers, then you have to have the last one, 5.6. Oh, but put the 16 as the hypotenuse and the 5.6 as one of the legs. The biggest number has to be the hypotenuse. Mm-hmm. Perfect. And then once you have your numbers, calculate your angles. Perfect. And I want to see both angles.
Oh,
Can you check?
I can, yeah. The one you're on. Oh, maybe not the one you're on. Slide 14 is what I'm looking at. Ooh. I think you did. I think I just checked yours. I think I just checked yours. Sierra Night. So you're going to do sign with the O and the H.
I don't know how to do the negative one thing. What is it?
So in your Desmo calculator,
Oh, no, I haven't do that. I'm just talking about that.
Mariah, perfect. Oh, mm-hmm.
No, I'm working. I don't even know what I'm doing.
Ariana, I got a slightly smaller number. Did you check to make sure yours is really a Pythagorean, like the Pythagorean theorem works? So, yeah, I use tangent and I got a different angle for you, but in Pythagorean, yours doesn't quite work for Pythagorean theorem. If you have a right triangle, though, it should work. If you really have a right triangle. And if you have an isosceles triangle, both sides are exactly the same. The two legs are exactly the same. It should be 45 degrees and 45 degrees. So if you have an isosceles triangle like 7 and 7, you want to make sure that you've done that correctly. But I think everybody's kind of got the hang of it.
It's totally very expensive.
Nice, Kayla. So Kayla, I'm waiting to see your angle. I see you've got 1.2 and 3.8. and 3.1. It's not working.
No, I think I might have
Okay. I think we're getting it though. So I'm
I
gonna.
don't think it's right.
You don't think it's right?
It's basically saying 1.
Is it in degrees or is it in radians?
Oh, well, I think it's the negative.
You check mine.
I will. I'm pretty sure. Ooh,
I think I checked mine.
I thought I checked yours already. Elias is good. Sterling.
It keeps saying delete.
Mariah. Yeah, I checked yours. The 13.9 and the 6.5. Yep, that's perfect. That's perfect. So we only have a couple more minutes. I'm going to take you guys over to the other side of the room. If you can look in my camera for those who are out in Zoom land. You see all that cardboard sitting on the side of my room?
Yeah.
Yeah. So that's going to be built into a planetarium. What the 5 students in class did for me yesterday was they put together 5 of these isosceles triangles into pentagons. And the way I built the triangles is they told me the directions, told me what the side lengths were supposed to be. But in order to figure out how to actually draw them, I had to divide those in half and make 2 right triangles. So ultimately, that's what how we're gonna figure out isosceles triangles. But we've got to get good at this before we can even attempt that.
I never did that.
Ultimately, you are going to you're gonna learn how to do that and create your own dome, whether you're at home or here. You will get that mission accomplished. Now I have my computer back hooked up. Maybe I can get my Zoom back. It's weird to me to not be able to see you guys. But that's our task for today. Just learn the SOHCAH-TOA, the sine, cosine, and tangent, be able to identify opposite, adjacent, and hypotenuse.
I got a different answer.
You got a different answer? What'd you get?
I got 76.4.
I think that is what I got. Let me look through my calculator history. 26.4. That's closer. Yeah, that's within range of what I got. Okay. How are we feeling about sine, cosine, and tangent? Can we find angles?
I feel like it's easy.
Okay. How about everybody else? I'm a little hungry too. It is definitely lunchtime. So lunch is in 3 minutes, actually. It's not right now. 12:40, exactly. I'm going to share my screen just to make sure that you know what I'm looking for at the end of the day today. Okay. So what I'm going to go check today is this slide in your pear deck. Make sure this slide with all of those angles is complete. We did it together. You should have it done. If you don't have it done, you can easily use the trig to find those missing angles. Okay. The second thing I'm going to look for is I'm going to look for 5 problems done on this set of slides. Okay. So I don't care which 5 problems you do, but if you don't have 5 problems done yet, you need to have 5 problems done. You don't have to submit the pear deck. So if you were doing it on pear deck, when I close the